Hello, my name is Steve. Welcome to my YouTube channel. In this video, I will show you how to determine a function is continuous at a given point. When we're saying a function is continuous at x equal to a, the function must meet these three conditions. The first one is fa is defined, which means this a, the point we are choosing, must be in its domain. We can find the actual value of the function when x equal to a. Okay, so fa. When you show on the graph, would look like this. Okay, so we can find the actual value of the function when x equal to a. Okay, so we have the actual point for this function fa. And the second condition is the limit of the function for x approaching to a from a negative side equal to the limit of the function when x approaching to a from a positive side. The x is approaching to a from negative, so here's negative, from negative equal to the function, the limit of the function when x approaching to a from the positive side. Okay, so here's positive side. If these two limits are equal, then we have to check the last condition. The function at x equal to a equal to the limit of the function when x approaching to a. If they're the same, then we combining these three conditions, then we can say that this function is continuous at the point x equal to a. If the function is continuous at all the points and its domain, then we can say this function is a continuous function. Okay, let's have a look. Three sample questions over here. The first one, y equal to 1 over x when x equal to 0. Since 1 over x, we can't have a x equal to 0 as a denominator, which means the f0 is undefined, right? Which means this one doesn't meet the first condition, okay? And also this one doesn't meet the second condition as well. When we draw the graph of this function, is a hyperbolic function, right? When the limit of the function approaching to 0 from a negative side, so the limit x approaching to 0 from a negative side, fx, is approaching to 0 from negative side is this one, is equal to negative infinity. And the limit of the function when x approaching to 0 from the positive side, from positive side approaching to 0, is the limit will be positive infinity, right? This one doesn't equal to this one. Okay, so this one doesn't meet the first condition and also doesn't meet the second condition. Okay, so this one is not discontinuous. So the first one is discontinuous. Okay, the second one, y equal to 1 over the absolute value of x when x equal to 0. This one we have a different curve. When we have an absolute value for the x, we have the same value for y, right? The limit of the function approaching from a negative side equal to from the positive side. At this function will be the limit at the function when x approaching to 0 from a negative side equal to the limit x approaching to 0 from the positive side, right? This one meet the second condition. This one meet the second condition, but this one doesn't meet the first condition. We can't have a 0 as the denominator, right? So we can't have, so f0 is undefined. So this one doesn't meet the first condition. Then this function is discontinuous as well. Discontinuous. Okay, let's check the last question. The function equal to x squared minus 3 when x less than 3. The function equal to 2x minus 3 when x is greater than or equal to 2. let's check the point when x equal to 2. Okay? Okay, we can check it step by step. The first step, we check the first condition. First condition, fa, so would be f2. So when x equal to 2, we're choosing the function equal to this one. So it would be 2 times 2 minus 3 equal to 1. Okay? Okay, the second condition is the limit of the function when x approaching to 2 from a negative side equal to, approaching to 2 from a negative side, we are choosing this function. Okay? Would be x squared minus 3. So x approaching to 2, this would be 4. 4 minus 3 would be 1. Okay? So the limit of the function when x approaching to 2 from positive side is choosing this one. Would be 2 times x. 2 times x minus 3 equal to, so 2 times 2 would be 4. 4 minus 3 is 1. So they are equal, right? So these two are equal. And the last condition is f2 equal to the 1, 1, 1. They're all equal, right? So f2 equal to the limit of the function when x goes to 2. They're all equal to 1. Then we can say the function is continuous at x equal to 2. Okay? We can check the function based on these three conditions to see whether this function is continuous at a specific point. Okay? So why we have to determine a function is continuous or not? Because in calculus, when we're doing derivative, we only derive a continuous function. We can't derive a discontinuous function. Okay? For example, when we're using derivative to find the maximum or minimum of the function, we have to make sure that the function is continuous. Otherwise, we can't find the maximum or minimum. Okay? Yep, that'll be all for this video. Thanks for watching. I'll see you in the next video. Bye-bye.